As we start into the next lesson, we start to look at sets of numbers in a little bit of a different way, and we start to introduce the idea of a function and what a function is in math. Now, it's very important that you learn the definition of a function because Algebra 2 is just basically your introduction to the most basic functions in math. And then as you progress further into different mathematics, higher level mathematics, you just extend that knowledge of functions and the different types of functions that you know how to deal with. So we give you a good little running start in the first handful of lessons. So we start, however, before getting to a function, just by defining what a relation is. And a relation is just really simply a pairing of values. So we have one value paired up with a second value, and we call these values the inputs and the output values. Now, in this particular lesson, terminology becomes extremely important, so you must know the language because the language is going to guide you to the answer. And most of the time, the terminology is simply stated in the directions and asked in the question. So be sure to pay real close attention. Even though there's not a lot of problem solving going on here, there's lots of very important information. So as we look, whenever you have a relation, you can represent a relation in a number of different ways. One of the ways is through a mapping of diagrams. We can have tables, graphs, equations, and verbal descriptions. And the input values are what represent what's called the domain of the relation, and the output values represent the range. And so we're going to kind of start keeping up with a little bit of a table, if you will, as we go through this. So I'm going to go to another Microsoft document. I'm just going to kind of point out a few things. So let's just start real simply with an input and an output. And so we can simply start right there. Now, an input and an output can also be represented or labeled as the domain and the range. And so just going to kind of start a little table right there, and by the end of this lesson we should have that filled out a little bit more. So let's go back to where we were. Now, if we want to take a relation and make it a function, what has to happen is the relation of the function, the relation is a function provided it has exactly one output for each input. So it's not a function if at least one input has more than one output. So basically, if you see the input twice, then it cannot be a function. And so we're going to learn many different ways to identify that situation. So we'll just start with the basic ways of looking at relations and determine whether they're functions or not. And the simplest way is visual, and we're going to do that with what we call a mapping diagram. So let's take a look at example number 1 real quick. It says to identify the domain and the range for each mapping diagram. Tell whether the relation is a function or not. So what we have here is we have the input and the output, and if you recall, the input represents the domain, the output represents the range. And so we have all of the values that represent the domain will be consisted with -3, 1, and 4, and you can see how we write this as a set of numbers. As we move over to the range, we have 4 numbers instead of 3, and so the set of numbers is a little bit larger. Now, the second part of this question says to determine whether it is a function. And so if we look very closely, the one value in the input value is being repeated. It is used twice to match up with output values. And so if we look at the definition above, it can only have exactly one output for each input, or it cannot have any repeating input values, if you will. So if we look at this, it's very simple from the mapping diagram visual to tell whether it's a relationship, if the relation is a function or not. And in the case of part A, it is not. Now, if we move down to part B, again, identifying the domain, very straightforward. It's all the input values. The range is all of the output values. Now in this case, our input values each have one output value. As you can see, the output number 1 is used with 2 different inputs. This is okay. This is still a function because none of the input values are repeated or used twice. And so it really doesn't matter if they go to the same output value or not. And so you can see visually the difference between a function and one that is not a function. And so this is very important for you to grasp right off the bat. We look at sample problem number 1 here. And sample problem number 1 asks us simply to identify the domain and identify the range and tell whether it's a function or not. And so go ahead and pause the video and see if you can use the previous examples to help you with this. Okay, so let's just simply take a look. We'll start with the domain, and I'll just say the domain represents the set of values that are all the input values. So -1, 1, and 2. The range is going to be represented by all of the output values. And of course, I should write these in numerical order, which is appropriate for writing a set of values. Now, if we look at it to determine whether the relation is a function or not, we can see very simply that our -1 input value is actually being used twice, so there's a repeat. So this relationship is not a function, okay? And it's as simple as that. For our next step in the progression of learning about relations and input and output values, we move to something that you should be familiar with from your Algebra 1 classes, and that's the sense of writing a relation as an ordered pair, or an XY coordinate, as you may have heard it called before. So I'm not going to go through the finer details of plotting X and Y coordinates. If you have any trouble with this, be sure to ask your teacher, but as in general, the X coordinate is first and Y is second, and the X-axis that represents the number line for the X coordinate is the horizontal axis, and the Y-axis, which is the number line that represents the Y values, is a vertical axis. And so that creates what we call a coordinate plane. Now, in this coordinate plane, the X and the Y-axis create 4 quadrants, and where they intersect, we label that with the point O, because it represents the origin where X and Y both equal to 0. Now, this is an extremely important topic, not only for this particular subject, but this is a big-time ACT topic that you should be very familiar with and where you can pick up some easy points. Now, how does it fall into what we're learning here today? Well, the XY ordered pair represents a relation, and since the X is the first value, it is considered the input value, and then the Y value is followed and is considered the output value. And so if we go back to our little table that we were working with a little earlier, we can see very simply that now the X's, which is considered an input value, must also represent the entire domain. And so if we wanted to write the domain as a set of values and we were looking at a coordinate plane, it would be represented by all of the X values on the points that are represented in the coordinate plane. If the Y value is representing the outputs, then all of the Y values that are plotted on the coordinate plane must represent the range. And so this is a good quick introduction how to transition your graphing of points to domain and range values, or domain and range sets. And so we just continue here to fill in our little table. So let's go back to where we were before. So now knowing the quadrants is very important. Knowing whether the X values or Y values are positive or negative in the various quadrants is extremely important. And knowing that the X values represent domain and the Y values represent range is very important. So let's progress on down and see how that would show up in an example problem. So if we look at example number 2, example number 2 says just to graph the relation in example 1, and of course so we need to look back at example 1 in our notes, which was on a previous video. But basically we had input values and output values, and what we needed to look at is just how we could rewrite those input values and output values as XY ordered pairs. And so we're going to take each one of those values and rewrite them as an ordered pair. And so we have -3 matched up with a 3. If you look at the blue and the red mapping diagram on the first page of the notes, then we have 1 and -2. We also see that 1 is matched up with 1, and then finally 4 and 4. Now, if we plotted those points using the method that you learned in Algebra 1, we would get this kind of scatter of points. Moving forward to part B of example number 1, we could do the same thing. We could match up the input values with the output values to make an XY ordered pair, and then plot those points again. Now, if we were simply asked to determine by looking at the graph whether this set of points represented a function or not, And so they all are relations, but are they functions? We could look at a couple things. First, we remember that if it's a function, the x value, which is the input value, should never repeat. And so we can simply see this by drawing a visual vertical line, and if the vertical line ever hits 2 points at the same time, that means we have a repeat in the x value or the input value. So if we look at part A, I'm going to use a highlighter tool to represent this. If I draw a vertical line right there, we can simply see that I catch 2 of the points. That means that there was an x value that must have been repeated, and in this case the x value that was repeated was the number 1. And so if you recall from example 1, that was not a function. And of course, if I took sample B and I drew vertical lines to every single point on that graph, it would never hit another point. And so in this case, it is a function. Now, this is just a random set of points, and so even though they pass the vertical line test or the definition of a function, it's not the way that we would necessarily think of a function in terms of Algebra 2. So we'll get into more detail about what those functions will look like, but they technically pass the definition and the vertical line test, which will be a good use of visual representation. So let's get some practice at this. Sample problem 2. Now what sample problem 2 wants you to do is to go back to the beginning of this notes to sample problem number 1 and take the mapping diagram of the input and the outputs and create a XY ordered pair with each relation and plot the points on this graph. And then once the points are plotted, then use the vertical line test to see if the relation is a function. So go ahead and pause the video at this point and give that a shot. And so if I take the input and output values from the mapping diagram that we had in sample problem 1, I would end up with the ordered pairs of -1, 1, -1, 3, 1, 2, and 2, -2. And so now I need to plot those. And remember, x values, y values. So -1 on the x-axis first, and then up 1. And then I can go -1, up 3 on the y value, and then 1, +2, and then a 2, and a -2. And so I've plotted all of the points. And you can see that if I draw a line, a vertical line, an up and down vertical line through each of the points, that in this particular case I hit 2 points that both have a -1 x value. And so this would be not a function. And of course we should have already known that from the previous sample problem that we worked on. Okay, so this is a good transition into showing how input and output values can be plotted on a coordinate plane and how to determine visually if those relationships are functions or not.